Welcome to this video on the architecture of modern computing. We will deconstruct the orchestrated ecosystem of hardware, data, and software that turns simple electrical signals into the intelligent systems we use today. Computing has followed an exponential curve, moving from ancient tools like the abacus to the invention of the transistor in 1947. Today, we rely on super large-scale integration, enabling millions of components to fit on a microscopic chip, just as Gordon Moore predicted in 1965. At the heart of modern computing is the von Neumann architecture. This design allows both data and programs to reside in the same memory space, enabling different components to function as a single, orchestrated unit that transforms input into output. The processor is the engine of this system. It comprises the arithmetic logic unit for mathematical operations, the control unit for managing instruction execution, and registers, which serve as high-speed, local workspaces for active data. We distinguish between two types of processors, the microprocessor and the microcontroller. While the microprocessor acts as a powerful the microcontroller is a designed for specific, repetitive functions in devices like appliances and IoT hardware. Input and output devices bridge the digital divide. Sensors and translators convert physical data into a digital format the system can understand, while output devices turn processed digital information back into forms we can interact with, such as screens or 3D prints. To manage speed and capacity, computers use a memory hierarchy. This ranges from lightning-fast registers inside the CPU and cache memory, down to primary RAM and massive, permanent secondary storage devices like SSDs and hard drives. Digital data scales from the fundamental binary bit. 8 bits make a byte, and from there we climb an exponential ladder of units: kilobytes, megabytes, gigabytes, and terabytes, all the way up to the yottabyte. Communication between these components happens via the system bus, a 3-lane highway. The data bus carries the cargo. The address bus sets the coordinates for memory locations, and the control bus acts as the traffic lights for operations. Data itself comes in many forms. It can be structured, like an organized record, semi-structured, like HTML with internal markers, or unstructured, like raw images, audio files, or video frames that lack a predefined model. Every piece of data follows a life cycle. It is captured by input, stored in memory, retrieved by the operating system for processing by the CPU, and eventually deleted or recovered when no longer needed. Software acts as the invisible commander. It includes system software that forms the foundation, programming tools used to build other software, and application software that provides the interface for end users to perform specific tasks. The operating system is the ultimate resource manager. It coordinates hardware, memory, and security. Over time, interfaces have evolved from text-based command lines to graphical user interfaces and modern intuitive touch-based controls. When you tap a screen, this entire ecosystem springs into action. The OS interprets the command. The CPU fetches the necessary data. The ALU executes the logic, and the final result is rendered back to your display, all in an instant. As Alan Turing suggested, intelligence is often about the illusion created by the machine. Through the complex orchestration of architecture, memory, data, and software, hardware becomes more than just an engine. It becomes a gateway to the digital world.